This is the solution to number 83 from section 3.1. Here we're told that the height y in feet of a ball thrown by a child is given by this function. Y equals negative 1/12 x squared plus 2x plus 4. X is the horizontal distance in feet from the point at which the ball is thrown. So I've made a little sketch here where you can see the path of the ball in red. X is the horizontal distance in feet, and y is the vertical distance in feet as well. So part A asks us to find how high is a ball when it leaves the child's hand. This is asking us to find the y-intercept. To find the y-intercept for a quadratic function, or any function for that matter, we're going to let x equal 0. So we're going to evaluate this function when x is 0. So that'll be negative 1/12 times 0 squared plus 2 times 0 plus 4, which is simply 4. So the y-intercept is a 0.04. And here we can say the ball is 4 feet high when it leaves the child's hand. So that means the y-intercept, this point over here, is at 0,4. The next thing is, what is the maximum height of the ball? When you see maximum, you should be thinking vertex. And since it wants to know the maximum height, this is asking us to find the y value of the vertex. In order to find the y value, it will be helpful to find the x value because this function is given in general form. So the x value of the vertex is going to be at negative b over 2a. For this particular function, that's going to be a negative 2 over 2 times negative 1/12. So we can go ahead and cancel out these 2. So this will become negative 1 over negative 1/12. And then we can multiply the fraction in the numerator, negative 1 over 1 times the reciprocal of the denominator, negative 12 over 1, which will become 12 feet. Okay, so the x value of the vertex is 12 feet, and we want to find the y value, so we'll evaluate the function when x equals 12, so that's negative 1/12 times 12 squared plus 2 times 12 plus 4. Negative 1/12 times 12 squared is negative 12. 2 times 12 is 24 plus 4. And negative 12 plus 24 plus 4 is going to be 16 feet. So the maximum height of the ball is 16 feet. And if we go back to our graph of our function, that means the vertex here is at 12, 16. The last part of the problem asks us to find how far from the child does the ball strike the ground. So in this case, it's asking us to find the x-intercept. So we need to find the x-intercept here. In order to find the x-intercept for any function, we let y equal 0. So we're going to let y equal 0 and solve for x. So here we'd have 0 is equal to, I'm going to put the function in vertex form because it's a little easier to solve. So in vertex form, our function will be x minus 12 squared plus 16, because that's the vertex, and the a value of the function, or the vertical stretch factor, is the same regardless of the form. So in general form, the a value was negative 1/12, so in vertex form, it's also going to be negative 1/12. And now let's go ahead and solve this. If you wanted to, you could also solve from general form. Here you might want to use quadratic formula or completing the square to solve it. So I'll bring the 16 to the other side. So I'll have negative 16 equals negative 1/12 times x minus 12 squared. I'll multiply both sides by negative 1/12. Oh, not by negative 1/12, sorry. I'll multiply both sides by negative 12. So I'll multiply this by negative 12. 16 times 12 is 192, so the negatives cancel out. So I have positive 192 is equal to x minus 12 squared. I will extract square roots, so take the square root of both sides. X minus 12 equals plus or minus the square root of 192. 192, I'm looking for a perfect square factor, is actually 64 times 3. So this is the same thing as plus or minus 8 rad 3, because the square root of 64 is 8, is equal to x minus 12. and then I'll add 12 to both sides. So x is equal to 12 plus or minus 8 rad 3. These would be our two x-intercepts. If we get a decimal approximation, 12 minus 8 rad 3 is actually less than 0. 12 plus 8 rad 3 is approximately equal to 25.9 feet. The value that's less than 0 is not relevant. That would be the value before the ball is thrown if I continued the function. That's not relevant. So the only value that's relevant is the positive value, which would be over here. And this is the value 12 plus 8 rad 3, 0, which is about 25.9 feet, comma 0. So to answer our question, the ball hits the ground. 8 rad 3 plus 12, or 25.9 feet from where it was thrown.